Hello everyone, welcome to this video. In this video we are going to study about the next property of isomorphism, which states that if we have an isomorphism phi defined from some group G to the same group G, then in that case if we take two elements A and B from the group G, then A and B would commute if and only if their mappings phi of A and phi of B commute, and vice versa. If phi of A and phi of B commute with each other, then A and B also commute with each other. So let's move ahead and prove this thing. So we wanted to prove that phi of A is phi of A multiplied with phi of B, this is equal to phi of B into phi of A. This thing is there when we are having the group operation as multiplication, right? So here we are assuming that A and B commute, so that means AB is equal to BA, right, for all A and B which are members of the group G. So what we do, we take the left hand side here. For the left hand side we have phi of A into phi of B. This is equal to phi of AB. Why? Because by the operation preserving property, right? By the operation preserving property. Then this thing is equal to phi of BA. Why? Because we are assuming that AB is equal to BA by the commutativity, and this thing again is equal to phi of B into phi of A. Why? Because again we are having the operation preserving property, right? So this proves that if A and B commute with each other, then in that case both phi of A and phi of B also commute with each other. Conversely, we wanted to prove that assume that phi of A into phi of B, phi of A into phi of B is equal to phi of B into phi of A. So that means both phi A and phi B, they commute with each other. To prove AB is equal to BA, we wanted to prove that A and B also commute with each other. For that, let's take the left hand side here. We have AB, right? When we apply phi onto it, right, on AB, when we apply phi onto it, we have phi of AB, right? This is equal to phi of A, phi of B. Now because they commute with each other, this is equal to phi of B into phi of A. Now again by the operation preserving property, it is phi of BA, right? So we have phi of AB, so we have phi of AB is equal to phi of BA, right? Now as this phi is an isomorphism, this is known to us, right? This phi is an isomorphism. Now because we wanted to prove that AB is equal to BA, we will be using this thing, phi of AB is equal to phi of BA. So it is also 1 to 1, right? If it is 1 to 1, so what does it mean? It means that phi of AB is equal to phi of BA would imply that AB is equal to BA, and this is what we wanted to prove here. So I hope you understood this result well. Well, that is it for this video. Thank you for watching.